Hello and welcome to this video on proportions by using chi-square. This might be useful for you, your future thinking, and potentially some of the exercises in this class. So now you already have an understanding of analysis of variance, I'm sure. And remember that it's great when you have the right kind of data. Analysis of variance is to test the differences between means or averages, and for that you need ratio interval data. But what do you do if you don't actually have that? What if we have a categorical type data, nominal or ordinal variables? Well, we do need to do a proportion test here and see and test if proportions are different or if they are above a certain threshold level. Now, we have three possibilities of how to test that. We can use a z-test or a z-test, as I would have called it in my original home country, a t-test or a chi-square test. You would have used z-tests and t-test, I'm sure, in other classes, and you may even have completed a chi-square. So either this is a revision for you or this is something that you want to be exploring in a little more detail for you now. So hopefully this is a quick overview of how it all works. And I'm very sorry, it looks as if we just had a short drop out of our video, but you haven't actually missed something. So whilst t-tests and z-tests are useful, they are somewhat limited because you can only test a single proportion or two proportions against each other. Often in product development, we actually have much more complex situations. We have more complex pictures that we want to look at, and often we want to compare more than two things against each other. So we might want to look at more than a 2 by 2. The chi-square test is great because it can handle the simple task of a 1 by 2 or a 2 by 2, but it can also go ahead and do 3 by 3 or even more. If you have a look at the cube here, you know that it is possible to do much more complex things. So today, don't worry too much about that. We're going to go on and do a straightforward example with really quite simple numbers in it. And if you do want to know how a 3 by 3 works, right at the end, I actually have a blog link that you can go and have a look at, and I think it works very effectively for you. So let's look at an example. So you're a director of marketing at a telecommunications company, and you've been wondering whether or not your new cell phone that you're developing should have Bluetooth access. Now, I do realize that in today's thinking, we'd look back and think, of course, that's an obvious thing that you want to do. I thought this might be a fun example because at the time, it would have been a quite significant decision for a marketing director to make, and clearly there are costs to that. So you're savvy, you're a marketing director, so you want to go out and do some research, and you have on hand a sample of 200 respondents. And you're probably, if that's the case, at stage 3 or even stage 4 of your business case. So you've already been through the ideation and or the scoping stages, one would think. So you wouldn't spend this kind of time, effort and resource at stages 1 or 2 most likely, but now you're at potentially the business case or even the development case. You really do want to be sure about what it is that you are doing. So you have 200 respondents. From these respondents, you want to be able to understand whether or not it's more likely that they're going to buy the phone if it has Bluetooth. That's essentially the managerial question of what you want to answer. Statistically speaking, remember that we cannot demonstrate causality in this situation. We need to be very careful about that. But a manager, a leader, might actually be much more forthright in the way that is put together. But ultimately, what you're deciding is yes or no to Bluetooth, and you're investigating the impact Bluetooth on potentially the buy or not buy decision in amongst this 200 respondents. Now, so what we're going to use is a two-way tabulation, simple table, or you might call it a crosstab or a 2 by 2. And it shows in this format what the responses are for people who saw the phone with Bluetooth access. So in this row here, we have respondents who saw, and we split it into two groups of 100 on each of the two groups. So the one group saw the Bluetooth, 80 of them said yes to buy, and 20 of them said yes to not to buy. The control group, it's exactly the same looking phone, it does everything the same, but it doesn't have Bluetooth access. Will they buy the phone? 20 say yes, 80 of them say no. Once again, 100 here, 200 in the sample size, and we have the no's 100, and the yeses we actually have 100 here. So this is the scenario. Now we have to decide what to do, what we found in this sample. The sample clearly is suggesting that there's an effective Bluetooth access. Is this something that we can rely on if we're actually going to spend more money on development? Let's look at the hypotheses that we're actually going to get out of this situation. So these are the hypotheses. There's a null hypothesis and an alternate hypothesis. So our null hypothesis is saying there is no association between Bluetooth access and buying the cell phone. The two variables are independent of each other. There is some association, the alternate, between Bluetooth access and buying the cell phone. The two variables are not independent of each other. Now, here we go ahead and conduct the test. So the test compares the actual or observed cell frequencies in the cross-tabulation with a corresponding set of expected cell frequencies. So what we're actually looking at here is what you would observe, what you observed, and what you actually expected in this situation. So what does this mean? So the black numbers are the numbers that we already know. So 80-20 and 20-80, they're the numbers we know. So that's what we observed. The red numbers are what we would expect, these numbers here. These are the numbers we would expect if there was no relationship between Bluetooth and buying. And how did we actually get those? How did we actually get those numbers? So here's the formula that we're actually going to use. I have provided these slides for you so you can actually have a closer look at this. So basically it's a multiplication of the marginal frequencies divided by the total number. So the marginal frequencies are here. I'll just pop this up for you again. Marginal frequencies, total number here. 100 multiplied by 100 divided by 200 gives you the number of 50. Now, we now want to apply the chi-square statistic. Again, this is fairly simple. It's a simple calculation, and this is what we're going to focus on here. I realize this is a little bit fuzzy for you. I've given you the slide pack so you can go and have a look at that first. So we're going to focus here on the centerpiece. So what we do is take the observed value, the one that we actually have, in the cell minus the expected value, the red number. So we square the result and divide it by the expected value for that cell. We do this for each cell separately. Each cell has its own separate calculation of a chi-square. And once you've completed that, you add all of those up and you get to, in this case, 72. And here's the formula for you at the bottom. This comes out to 72 for you. Now, so the chi-square statistic, the empirical chi-square statistic, that is easy to calculate. Now what you need to do is, as with any other test sample, you're going to actually compare that to the critical value. So let's go and find the critical value. And this is how we're going to do this. So for the chi-square, the statistic, it's important to know the degrees of freedom. Now remember that a degree of freedom in the vernacular is how free the values want to be. Now you probably have read that or heard about that somewhere else, but the degree of freedom for chi-square is simply the number of rows minus 1 and the number of columns minus 1. 2 rows, 2 columns, 2 minus 1, 2 minus 1 is 1. 1 multiplied by 1 is 1. So the degree of freedom is the number of rows minus 1 times the number of columns minus 1. it gives you the degree of freedom of 1 in this particular case. Now, assuming that you want to be 95% sure, so you take the alpha of 0.05. Now make sure that you've got a chi-square statistics sheet somewhere. I've also provided for you a formula that you can actually use in Excel. If you go and look at your slide pack, you'll actually be able to do that. So you can do this in Excel, and that's probably an even easier way than to go and find your check sheet. So then the decision rule is that then reject the null if my observed empirical chi-square is larger than 3.84. That was the number that we actually found in our calculation here. So now we're going to continue with this situation. So given that the decision of my computed chi-square of 72, the answer's clear. I'm rejecting the null. While there's no association, so therefore I'm rejecting the null, which means I'm accepting. So yes, there is an association. There is a relationship between Bluetooth and buying. So therefore I would suggest to the telecom company that you'd want to put Bluetooth on this phone. Now let's talk about what all of this actually means. So you can be a little more precise, even by more precise by looking at the actual significance level or p-value that's the 72 observed chi-square. How do I find that? Use your table, but you can also use Excel. And again, I provided the equation for you here. We're almost at the end. So the simple fact is that the number is going to be very small when you think about that. There's no, so there are a number of precautions that you want to be really thoughtful about here when we're actually looking at the likelihood, the impact of one particular variable on the likelihood of an outcome of another one. And I do want to remind you this. These are some precautions to think about. Firstly, this is not providing evidence of a causal relationship. Please remember that. This is providing evidence of an association. In the cells that we had numbers of 80, 20, we had a sample size of 200. You want to be very careful when the cell sizes, the numbers in this cell are actually small. And we sort of as a rule of thumb, we tend to say 10 is a useful number. Now, the final point here is that they're also multi-way chi-squares. So it would be unusual that in this kind of experiment we'd only be using, say, Bluetooth and likelihood to buy. So there might be some other situation. It could be the size of buttons or some layout on the screen. You can imagine how this was used in the development of the very first iPhone, for example, and on it went. So you can move on to 3 dimensions and so forth. So there you are. I hope this has been useful to you. Go and have a look at the blog entry here. That's going to help you with more complex situations. And take care and enjoy the rest of the course.